Hello, Dave here with a RAM upgrade video. I'm going to upgrade the memory on my main workstation, the AV Editor computer, which is what I'm working at right now. Currently, this has 16 gigabytes of DDR4 2133 RAM. It's installed as 4 sticks, 4 gigabytes each. I'm going to upgrade to 32 gigabytes of RAM. The reason for the upgrade is because I'm starting to get real close to the maximum when running virtual machines, conducting webinars, and editing large videos. And you can see this in the task manager that's open now. Right now I'm using just about 14 gigabytes of RAM and only 2 gigabytes available. And you can see that up here as well. So look, the line is all the way up here. Not good. We don't want to really be that high. For best performance, I like to keep the in-use RAM at about half of the total. I mean, we're still functioning here, but I like to do that. That's kind of a rule of thumb. Now, I'm running a lot of stuff right now, including virtual machines, which you don't see in the Processes tab. You don't see that there. You have to go to your Performance tab to actually see all the memory that's being used. And there's other ways to do it as well, other tools in Windows and also third-party tools, right? So we want to increase the total so that when I'm doing all these things, I don't get real close or use up all the RAM, and then we run into system performance issues. Now, I just ran a Passmark performance test, the memory mark test, and here's all the results from that, which I've saved. Once we do the upgrade, I'm going to do another test and compare it, and compare the baseline. And you can see the total score here is 2681, not bad. That actually puts us at the 89th percentile worldwide, which you may or may not be interested in. But total score here, and here's the other information, which we'll compare. Now, it's interesting because I installed this RAM 3 years ago on this system, so it kind of gives you an idea of how much RAM really changes over the course of several years. Of course, it was somewhat cutting edge when I installed it. All right. Now, I also ran HW Monitor, which you can see here, to check the temperature of each of the sticks of RAM. And here's the 4 sticks, generally around 39, 40 degrees. This one runs a little cooler, and that's under load right now. So that's what we want, and I'm going to test that again under the similar load later after we do the install. Okay, now the problem is that this RAM is 2133 megahertz RAM. The problem is that that is not available now without losing your life savings. So for example here's the RAM that I installed. This is the RAM, 2133 megahertz, 4 gigabyte sticks. I installed 4 of these when I first built the computer for 16 gig total, and the total cost was $172. Now we have some guys out there that are trying to rip everybody off for this older RAM, charging $179 per stick. Right? So I can't find the 2133 megahertz. So I decided to go one step higher and go with 2400. So it's something to think about. You may want to load up on RAM when you first build, because later the RAM might be hard to find, or it might cost you an arm and a leg. You might lose your shirt on this deal. And I don't want to do that, right? Now, I understand you're probably under a budget. I was under a budget too, so I did the 16 gig. RAM is volatile, though. Not just the contents of RAM, but the prices are volatile. Now, planning is essential. The first thing you want to do is decide, what can we use? Will it work? Right? So we want to go to our motherboard documentation, and this computer uses a Asus X99-A motherboard. We'll go to the specifications here, click on that, and make this a little bigger. All right. And for memory, it says we can have 8 DIMMs, there's 8 slots altogether, of DDR4, a maximum of 64 gigabytes. And the highest speed is 3000 megahertz, but it says OC, which means overclocked. The lowest speed, which I installed, was 2133 megahertz, which was the only speed available on the motherboard without doing overclocking, which is what I wanted because it was going to be my main workstation. I didn't want to risk any type of overclocking. Now, to do the upgrade, I kind of have to, but I'm going to minimize that risk by just going with the first level, 2400. And what you want to do is you want to make sure it'll work. Now, that means that you have to have XMP, Extreme Memory Profile, enabled, which it could be a switch on the motherboard, or it could just be a setting in the BIOS or UEFI. And then you have to make sure that the RAM is going to be compatible with your motherboard. So you have to check whatever site you go to. I went with Kingston RAM, but whether it's Kingston or Corsair or whatever, you want to make sure it's compatible with the board. And then you want to make sure that that type of RAM with that overclock on the board will work with your individual CPU. And really the only way to do that is to check and see if other people have done it, which I have done. I've checked and made sure that it will work. But again, there's always risk with any type of overclocking, so you have to be ready for that. I think we've minimized the risk pretty well, so we should be in good shape. So you got to check the specifications first and make sure that everything will be compliant and compatible. Then we'll go down to the system memory charts, and you'll see here, this is an illustration of the board, CPU, and we have 4 RAM slots here and 4 RAM slots here, and they're labeled here and here. They're also labeled on the board. Now, if we scroll down farther, you'll see the various recommended configurations. There's other ones that you could do that may or may not work, but usually it's a good idea to go with the recommended config. You know, these guys that are building the boards, they do all this testing. Currently, I have 4 sticks, so they are in 1 stick per channel. A1, B1, C1, and D1. That's what we have. But I'm doing an upgrade, and I don't want to use these sticks just yet. I might incorporate them later, but that should be a separate process altogether. I'm installing a different speed RAM, so we want to make sure that that new speed of RAM works before we do anything else, and that's what this video is about. And it's a 2-stick kit. So this is the config right here. We want to do B1 and D1. So that's what we're going to do with that. And always check this stuff and have a plan ready before you actually go through with the install. Okay, so we have a plan, and let's go ahead and do the actual upgrade. Okay, so we have our computer here, and I've taken the case cover off, and you can see inside, and here is our RAM. We've got 1 stick, 2 sticks, 3 sticks, 4. These are going to come out. Now, before you do anything, you want to make sure you have your anti-static protection set up, which we do. And these are easy to take out. You need to release them by pressing to the side with this ear or lever or lock, whatever you want to call it, tab. And so we'll do that for each of these. You can do that with a tool. If you use any tools, make sure you use something plastic, not metal. But if you can fit your hand in, that works also, as long as you're grounded. So we'll do this one. And you just press it to the side and it clicks. Do the next one. And the last ones. Okay, that loosens them. Then we can pull them out. Now when we do that, we want to grab from both ends and pull up simultaneously. You want to make sure you're not moving from side to side with the RAM, because that could damage the contacts. So I'm going to try to pull straight up as much as possible. And so we'll do that now. Take this first one out, grab from both ends, pull straight up. Okay. And always try to handle it from the edges if you can, so that we don't damage any of the chips or contacts or circuitry. And then you want to have an anti-static bag available to you, or more than one, or old RAM containers to put that RAM in. So we'll put that to the side, and we'll remove the rest. Pull on the second one. Again, straight out with both sides at the same time. holding from the edges. And I'll do that with the rest. Okay, so we have no RAM. We have no memory. System can't do much without memory. So here is the new memory. And like I say, this is I'm putting in 32 gigs. 32 gigs of RAM. So here's one stick, and we've got another one. So they come in their RAM cases. We'll take those out. And before we do so, I want to make sure that we know exactly where we're installing those. And if we look at our documentation here, we see that we want to use the B1 and D1 slots. Previously, we were using A1, B1, D1, and C1. So what we want are the slots that are open right now that are closer to the CPU. So that's this one here. That is B1. And this one here, which is D1. To install the RAM, we can take it and make sure we're just holding it by the edges. And you want to line up the notch in the middle there into the slot properly. So for this one, we have to turn it around. And then we can place this directly into the slot. So it's got to be placed straight in. We'll press down. And when we do so, it should lock automatically. You probably heard a snap, and it locked in. That is our B1 stick. And we'll do the same for the other one. Now for this one, it's going to go in the other direction, because the slots on the other side are reversed. So this time it's going to go in this way. Find the correct slot. And it's a little tight in here, so sometimes you might have to one-hand it a little bit. Trying carefully not to touch any of the circuit boards. Slide it straight in, and then we'll press down until it snaps into place. There we go. And what I was doing was I was applying even pressure to both sides, trying at the same time, so that we don't bend the RAM and we don't bend the motherboard too much. You might have noticed it did have some movement, even though there's some standoffs on the motherboard between the motherboard and the case. There is always a little bit of movement. Never force it though. If it feels like it's not going, try not to force it. Okay, so that is the RAM install. The physical install really doesn't take very long. And so what we need to do now is just check, make sure there's no contact showing, make sure it's indeed pressed all the way down, both of those, and double check the slots. We want to make sure that we are installing to the correct location, and that's in your motherboard documentation. And I'm looking at that now, and it does look good, B1 and D1. Sometimes they're labeled on the motherboard, sometimes it's hard to find, but in this case, it's 2 slots away from this side of the CPU and 2 slots away from this side of the CPU. You can count that off from the documentation also in case it's not numbered or diagrammed well on the motherboard itself. All right, so let's case it up and get into the BIOS or UEFI or both and check it out. Okay, so I plugged everything in on the computer and entered the BIOS. Here's our UEFI BIOS utility for this Asus X99A board. And it sees that we have 32 gigs of RAM, DDR4, 2400 megahertz. Here's one, it's in B1, and here's the other, it's in D1 as expected, because we did that according to the manual. And so that looks good. Now you may want to go further. You may want to go to advanced mode and go into the tweaker here, the AI tweaker for this. We see the DRAM frequency is 2400. So it picked that up automatically. Now I mentioned there's an XMP switch. That's the extreme memory profile by Intel. Other boards will have something similar. sometimes you might have a switch for this on the motherboard. This motherboard does. So in some cases, you need to enable this, especially if you want to overclock. If we look down here and we look at the DRAM frequency, you'll see that we can make changes here. Now, the memory frequency is good. We're at 1.2 volts, so that's good. Capacity's right. Frequency is correct. 2400 is what we want. But you can go further. And in fact, this board goes all the way up to 4000. It only supports up to 3000 megahertz. But we could actually do that. We could overclock further. Overclock with caution, of course. So if I was to take the other RAM that I have that runs at 2133 and place that in separate channels, then I'd have to increase that frequency for that RAM. May not work at all. So that's a whole nother video altogether. But again, just remember, if you ever have to do any overclocking, you may have to enable that XMP switch on the motherboard or enable it here in the BIOS and then configure the frequency that you want to go to. But actually, everything looks good here right now. So we've got our RAM and we should be good to go. I'm going to reboot the system and we'll be back in the Windows section. And we'll do some testing and benchmarking and finish it out. All right. So we booted into Windows and Windows 10 started perfectly. And so I'm here in the system window within the control panel, and it's a basic place to go to see if you have the right installed memory. We have 32 gig here, and everything looks normal. So that's the first place you can go. Second place we can go to is the Task Manager. And we can see here we're using 4.1 out of 32 gig, about 13% right now. So 4 gig in use, and that's typical. And then we have available 27.8 gigs, so 32 gig total. Looking good so far. We'll bring up CPU Z, and I'm in here's the memory tab, and it shows the DRAM frequency here, and that's 1200 megahertz. Previously, this was 1066 to give a total of 2133. That's the internal frequency of the RAM. That's always going to be half of what it's marketed as. The internal clock, not too important for the A+. So we just double that, we get 2400, we're good. And if we go to SPD here, we do see DDR4 2400, it identifies it. All looks good here. And that's slot 3, that has one of those, and slot 7 has the other guy. Those are the slots that we're using for the RAM. Okay, so those are some tools you can use to take a look here. CPU-Z is a third-party program. Task Manager is built into Windows, of course. And so let's bring up the Passmark memory test. This is Performance Test 9.0, and we'll do the memory mark, and we'll run that now. Okay, so the performance test finished for the memory mark, and the results are just slightly better than what we had originally. And originally, you can see the results here, not really much different. And this partially depends on what's running on the system. So I did it the same way with nothing running. And honestly, this could be better or worse depending on when you do the test. Results can vary, but if we look at the final number here, we see 2681 and here 2710. Not much of a difference. And I didn't really expect much of a difference, even though it's 2400 megahertz. It's not really that big of an increase when it comes to working with RAM. Now, the old RAM, the 2133, that was using all 4 channels. That was set up as a quad channel. This is only set up as a dual channel. But quite often, dual channel may test worse, but it really behaves and performs pretty much the same when you throw real data at it. So that's something to think about. But at some point, I might turn this into quad channel. Either I'll add 2 more sticks that I've already added, or perhaps try to use the old memory and try to use them together one way or another. But it's good enough as it is now. This is fine. The key is that we want the 32 gig. Because I want to see what happens to this RAM amount when we run those virtual machines. So I'm going to bring that up now. And we'll start a couple of these up. I've got 3 that was running before. We had Windows 7. We'll power that guy on. Windows Server 2016. We'll resume that one. And Windows 10. And we'll resume that one. Okay. And it's looking good. Everything's starting up, and it's utilizing about the same amount of RAM as before. It's just that we now have the 16 gig available, so we could do a lot more. I could do a lot more of the things that I need to do simultaneously on this one system, and everything's kind of booting up at the same speed. But with a lot of these software benchmarking applications, you may or may not get exact results. So I'm going to do a little bit more testing with that and see how that does. As of now, it looks good. All the virtual machines are running, and everything looks like it's running well with this. And so that's about it for this video. It all looks good. So in this video, we removed the 4 sticks of DDR4 2133 RAM, and we installed 2 new sticks of DDR4 2400 RAM, upgrading the total RAM from 16 gig to 32 gig. Okay. I also checked the temperature of the RAM, and the temperature looks good in the BIOS and also with HW Monitor. But the system does appear to be running well, and it should be able to handle just about anything I throw at it over the rest of its lifespan. So that's it. This is Dave signing off, and I'll see you at the next video.